Welcome dear students. Today we will be solving question number 25 of problem set 3 of chapter circle. As given in the question, you see segment AD is perpendicular to side BC, BE is perpendicular to AC, CF is perpendicular to AB, point O is the orthocenter where the altitudes meet. What we have to show that point O is the in center. We have to show that point O is the in center of triangle DEF. So here what we have, as it is, we know how to proceed with it. So we write given, then we write to prove, and then we do the construction. So first thing what we will do is we will just look at this triangle ABC, in which angle F is given as 90, angle E is also given as measure 90. Now we know that whenever there is a quadrilateral which is a cyclic quadrilateral, that means all its points are lying on the circle, then we call this as a cyclic quadrilateral. All the points are lying on the circle. So what happens is, what theorem is telling us is that opposite sum of the opposite angles, yani that means angle B plus angle D is equal to 180. This is cyclic quadrilateral theorem. But what we have been given here is, it is not a cyclic quadrilateral. They have just given us that angle F and angle E is 90. Together they measure 180. Therefore, what we will say is this quadrilateral AFOE is a cyclic quadrilateral and the points AFOE are concyclic. So that is what has been written here. You can see, right? OFA plus OEA is 90, 90. So together they are making a cyclic quadrilateral. Therefore, these points are concyclic. Now, what you see over here is, if I join this FE, what I get is here, if I join these points and draw a circle here, so these two angles, that is angle OFE and angle OAE, are inscribed in the same arc. That means they are congruent angles. Angles inscribed in the same arc are congruent. Segment OE subtends equal angle, angle OFE and angle OAE on the same side of OE. Therefore, OFE is congruent to OAE. What is the reason I'll put here? Angles inscribed in same arc. This is the intercepted arc and this is the inscribed arc. Okay. So now moving on, this is the first part we have done. Now moving on to the next part of it. If you observe this quadrilateral over here, OFBD. Now this is also a, you see the opposite angles measure 180 over here. Since they are measuring 180, so what will happen, this quadrilateral OFBD is a cyclic quadrilateral. If I draw it over here and say that this is a cyclic quadrilateral, because we have the opposite angles as 180 total by converse of cyclic quadrilateral theorem. Since it is a cyclic quadrilateral, what we have drawn the circle. Now OF is there. What we need to draw is this FD as well. Since we have done over here in the first part, you see FD is also drawn over here. You can see FD drawn over here. So the same thing I have drawn here. So now can you see two angles inscribed in the same arc? This is one of the angle which is inscribed here and this is another angle. We'll number it as 2 over here. So OFD and OBD are inscribed in the same arc, that is arc OFD. OFD, or you can say OBD, whichever, any three alphabets has to be there. So these points are again concyclic. Okay, so let us proceed with it further. So here you have angle OFD is congruent to OBD. You can see here OFD, here OFD is congruent to OBD. That's what is written here. So again the same reason I'll write here, angles inscribed in same arc. In this triangle ABC, what you see is triangle AOE and triangle BOD if you consider. So we'll just prove that these two triangles here, this one and this one, we'll prove them to be similar. So what we can do is, we will be just writing here. So here you see this is angle 90, this is angle 90. So in triangle AEO and triangle BDO, angle AEO and angle BDO both are 90 degrees. AOE, this is the vertically opposite angle, you can see here. They are vertically opposite angles. Therefore, the two triangles are similar to each other by AA test. Therefore, what will happen now? Angle OAE will be equal to OBD, the third angle, that is corresponding angle of similar triangle. First case, what you had, that angle OFE, I'll just write it here beside so that you will it will be easier for us to understand. Angle OFE is congruent to angle OAE. This is the first one you have. The second one is what? Angle OFD is congruent to angle OBD. This is your second one. And the third one is what? Angle OAE is congruent to angle OBD. Now this is the third one. So when you have both the OA is equal to OBD, that means both the RHS are equal. Therefore both LHS becomes equal. Therefore you'll write here angle OFD is congruent to angle OFE. OFD over here, if I draw, and OFE both become congruent to each other. Therefore, definitely FO, ray FO bisects angle DFE. Similarly, we can prove for the other angles as well. And so what you can say is this point O is the in-center of triangle DEF. So I hope this is very clear, children. If you have any other queries, you can put it in the comment box. And if you have liked the video, please subscribe to my channel, hit the bell icon, like and share. Till then, revise.